All right, let's try to get this example done. And then, what did I tell you yesterday? Just try to do as many as you could, right? But there's probably a lot that you wouldn't be able to do. Is that what I said? Okay. All right, just try and remember. I have a hard time remembering things anymore, it seems like. All right, so, well, let's draw the thing. Let's put a, let's use a graph. So let's grab this thing again. Come on. There we, oops. Okay. There it is. Let's put it right here. Let's make it a little bit bigger so we can see it. This thing is dragging. I don't know why it's not responding like it normally does. All right, that seems okay. All right, so we are trying to find. Let's see. Oh, it says use example 1 to find the slope, the length of the other two mid-segments of triangle ABC. So I don't have my book in front of me, so I don't. Let's see. Do I have example 1 in my notes? Example 1. There we go. All right, so. Well, I'm just going to draw what I have in my notes. Okay, so this is what we have. Let's write down a bunch of points. So ABC, all right? So, oops, what's going on? A, there we go. Let's get rid of that. Oh, not a very good start. Here we go. Let's try it again. A is -7, 1. B is 1, -5. And C is 7, 3. Okay? So, go ahead and plot those and make a triangle out of it. You do it yourself. All right? And then I'll do it in a second. Because I want to check out what this book says example 1 is. Actually, I want to look at example 3. Okay. So example 1, I think they were just asking you to find the midpoints of the 3 sides. So we've already found those in example 1, so we won't do all the work for that. But let's draw the triangle. Let's see if you plot the points right. So -7, 1, 2, 3, 4, 5, 6, 7, 1. So it's right there. All right, there's point A. Point B is 1, -5. So 1, -5, 1, 2, 3, 4, 5, right there. And let's label it while we're here. Let's call that A. Let's call that B. Then C is 7, 3. So there's 7, 1, 2, 3, right there. And that's C. So we got to make a triangle out of it. Did you make a triangle? Mm-hmm. All right, so you just connect them. Right, that's close. And this to there, and then this to there. All right, good. All right, so we got that triangle. So again, it says in example 3, use example 1. So this is example 1. And then in example 1, I think we had to find the midpoints. And I will just show you what our midpoints are. Instead of doing the work, all right, because you've already done it before, so we're not going to do it again. So D, E, F. So D, E, and F. So let's see. D was the midpoint of AC. All right, if you look at it, you can kind of see where it would probably be. It'd probably be right there, wouldn't it? But we did the work on example 1. You can go back and watch that video. I'm sure we found the midpoint of that. So that's the midpoint. I'll do it a different color, but let's do all the midpoints. And then E was the midpoint of BC. So So whatever the midpoint of BC was is point E. All right, and that is 4, -1. And again, we've already done the work to find those. And then the midpoint of AB was point F, and that's -3, -2. All right, so for this example, you didn't actually have to find the midpoints, but there they are. So if I know the midpoints, then I can find the mid-segments. Agreed? If I connect a midpoint of one side to a midpoint of another side, I've got mid-segments. So let's put those points in here. So this is the new part of it. We hadn't talked about mid-segment in example 1. So 0, 2 would be right here. Hopefully I drew this fairly accurately. All right, so that's one midpoint. 4, -1. 1, 2, 3, 4, -1. Yep, so far so good. Looks like it lines right up with where it's supposed to be. -3, -2. 1, 2, 3, 1, 2. That's pretty close. That's off a little bit, but that's not too bad. All right, so those are the 3 midpoints. So if I connect those midpoints, what am I making then? Well, another triangle, but what's the actual line segment from one midpoint to another? What do we call that? Mid-segment. Very good. He was the one that wasn't here, and he got it. All right, and then from there to there. All right, so if I connect the midpoints of two sides of a triangle, I get a mid-segment. Everybody got that? So these two sides right here, there's a midpoint, we connect them, that's a mid-segment. Okay, these two sides right here, I connected the midpoints, mid-segment. These two sides down here, I connected the midpoints. That's a mid-segment. Everybody with me? What did we learn about the mid-segment, though? That they're what? Okay, it's parallel to that third side. So, and let's put the points. Let's put the letters. 0, 2 was D, so we can. And then 4, -1 was E. And then the -3, -2, that was F. All right, so now we can at least refer to these by their proper names. So DF, or FD, doesn't matter, is the mid-segment between AC and AB. All right, so that's a mid-segment. DE is a mid-segment. FE is a mid-segment. All right, so DF, it connects the midpoints of these two sides, AC and AB. So what does that theorem say? It says two things. One thing it says is that it's parallel to the third side. So what's the third side? If DF is the mid-segment, what's the third side? The one that it doesn't connect. What is it? BC, right. So DF and BC should be parallel to each other. Okay? Everybody see that? All right, so this little one right here and this BC, they got to be parallel to each other. Now, how would we show that they're actually parallel to each other? How could I prove that they're parallel with these points? Find the slope. That's right. Okay, you find the slope. And what should be true about the slopes? They should be the same. Okay, they should be equal to each other. Everybody see that? So the slope should be equal. So we're going to do that 3 times. So we're going to find the slope. Actually, we're going to do 6 different slopes. We're going to do DF and BC, find the slope of both of those, okay, and then figure out if they're the same. If they're the same, then yeah, they're parallel. Then you're going to find DE, find the slope of DE, and then the slope of what? AB, right? DE and AB. If they have the same slope, if they're equal to each other, they're parallel. And then we find FE and AC, right? AC and FE, and if they have the same slopes, then they're parallel to each other. Everybody got that? So that's basically 3 things we have to do, but that means we got to find 6 slopes, which is really not that big of a deal. It's not that hard to find the slopes once you get used to it. What's the other thing about the mid-segment theorem that we learned? It's parallel to the third side, but the length of it, we learned something about the length. So let's do DE again, or DF, sorry, DF. See DF? What is the length of DF compared to the length of CB? It's half of it, exactly half of it. That's what we learned yesterday. Did you write that down in your notes? That it's half the third side? Okay, so the length, or the distance, the length of DF is half the length of BC or CB. All right, we got to show that. So how do we show that? How do I find the length of it? Come on. How do I find the length of a line segment? Find the what? The distance, right, the distance formula. Use the distance formula. We're going to find the distance. All right, so that means we're going to have to do distance formula 6 times. All right, so we got to do slope 6 times. We got to do distance formula 6 times. Actually, well, what I'm doing is I'm showing that it is half of this. Okay, so I got to find the length of that and the length of that. Let's say that's 5. I got to show that that's 10. If that's true, then they're mid-segments. Does it make sense? All right. So let's see. Did I do it 6 times? Why did I only do it 4 times? Oh, it just says find the slope and the length of the other 2 mid-segments of triangle ABC. So they must have found the slope and the length of one of the sides. Let's just find them all. Okay. So let's just do them all. So I'm going to keep these points right here because that's pretty helpful to us. And I'll probably draw here and just erase it, but you could keep going on your paper. All right, so what do we want to do first? Let's find that they're parallel to each other. So let's find that DF is parallel to CB. All right, so what are we going to do? We're going to find the what? The slopes. All right, so let's find the slope of DF. So slopes. All right, so let's find DF. So what's the slope of DF? We could just sit here and count on the graph if we wanted to, but it's a lot better, I think, to just use these points right here. D and F. How do we find the slope? It's the change in y over the change in x, all right? So df. So we subtract the y's from each other. Make sure you subtract them in the same order. It's very important that you subtract them in the same order. Let's just go the top one minus the bottom one, okay? So it's 2 minus what? Negative 2. It's important that you put that negative there, all right? And then do the x's. It's 0 minus what? Negative 3, okay? And that's what? 4, right? And that's 3. So that's your slope of df. We good? Now what are we trying to do? We're trying to show that they're parallel to each other, right? So now I got to find the slope of BC or CB. Doesn't matter which way you call it. So I'll just call it BC. So let's find the slope of BC. All right, so here's BC right here. So let's do the same thing. Find the slope. It's a change in y over the change in x. So it's negative 5 minus 3. And then it's 1 minus 7. Let's see if we get the same thing. That's negative 8 over negative 6. Well, that's not the same thing, is it? Well, sure it is. It's negative 8. Yeah, I did put a negative there. It's kind of hidden. But we reduce it, right? So if we reduce it, what do you get? Positive 4 over 3. That's right, because it's negative over negative, right? So do they have the same slope? Yep. So are they parallel to each other? Yes, they are. Tell you what, instead of doing this 6 times, let's just do it just for this one and this one, okay? And then if you want to do the others yourself, feel free. But just for the sake of time, you know it's going to work, all right? So we'll just do it for the one. All right, so we found that it's parallel to each other. What's the other thing that's true about the mid-segment? That the length of it is what? Half of the other one. So now let's do that, okay? So now let's find the distance, okay? And we're going to find the distance of df. And so we need a distance formula. So the distance formula is this. Why am I writing uphill? I don't know. What's that? I'm in a good mood when I write uphill? Is that what it is? No, I haven't heard that before. Oh, yeah? I don't know. After my first class, I don't know if I'm in a good mood or not. But you guys are putting me in a better mood, so maybe I am. All right? So what do we do? For df, find the distance. Right, you subtract the x's, okay? And again, on this one, it doesn't matter what order you subtract them in. On the slope, absolutely, okay? If you subtract the y's in a certain order, you got to subtract the x's in a certain order. Right here, the x's and the y's, it doesn't matter what order you subtract them. So let's just subtract the x's. So df, we've kind of already done that. It's 0 minus negative 3. What do we get when we got that? We just get a 3, right? Can you do that in your head? You should be able to do that in your head, right? And then let's do the y's. So again, it's df, so it's the first one and the third one. So the y's, 2 minus negative 2, that's what? 4, all right? And we've already done that math before, but we haven't done this. What's this going to be? It's the square root of 9 plus what? 16. And that is the square root of 25. It's not the square root of 5. Did I mark that on a quiz or something? It was somebody. It's not the square root of 5, it's what? It's just 5. It's the whole number 5. The square root of 5 and 5 are completely different numbers. All right? It's not the square root of 5. It's the square root of 25, which is 5. Okay? You got to get that right. We had a big talk about that yesterday, didn't we? Okay? So make sure you get that. All right. So anyway, so the length of this is what? 5. What do you think the length of BC is going to be? It's going to be 10. It should be, right? If this is half of this, this should be 10. Let's just see if it is. So we'll just do the distance right here. So the distance of, what are we doing? BC, right? I'll put a little BC right there. So the distance of BC, so square root, just writing like the shell of the formula. Now we're going to plug stuff in, subtract the x's. With BC, come over to BC right here, subtract the x's. Again, it doesn't matter what order. 7 minus 1 is 6. And then, what's this? 3 minus negative 5. What's that? 8, right? We got the 8 over here, didn't we? When we subtracted the y's, right? We got a 6 over here when we subtracted the x's, yep. And so, let's see, what do we get here? What's 6 squared? That's 36. What's 8 squared? That's 64. What's 36 and 64? It's 100, but it's the square root of 100. But the square root of 100 comes out even. What does it come out to be? 10, just like we thought it should. Okay? And it works, doesn't it? Okay? So this kind of, it's not technically a proof, but using numbers, it kind of shows that what we said about the mid-segment is true. All right, that the DF is parallel to the third side, that mid-segment is parallel to the third side, and the mid-segment is also half of the third side. The length of it, the measure of it, okay, is half of the third side. All right, so we showed it with that. Do you think it's going to work with the other two? Sure, of course it is. All right, but just, again, for the sake of time, we just did one of them. You could always do the other ones and see if it works out too. Now, does it mean that they're always going to come out to be 5 and 10? No, not necessarily. All right, it could, right? But not necessarily. But you're always going to find out that this is always going to be half of this, right? And it's always going to be parallel. So they're going to have the same slopes, and the length of one is going to be half of the length of the other. And that's it. That's example 3. Now you should be able to do all the homework problems, okay? Were you able to do any of them before we did this? Yeah, you should have been able to do most of them. Maybe a few at the end you weren't able to do. All right, but you should have been able to do most of them. So I'm going to give you the rest of the time. You've got, what, like 25 minutes, 23 minutes left. That's a lot of time. You should be able to get it done, and then you won't have any homework tonight. Isn't that nice? So what did I say, 1 through? And then, was that it? Or did I add more to it? Just 1 through 16? All right. So what I said on the, yep. Oh, and then 19 through 30. That was today's. So sorry. It's 1 through 16 and 19 to 30. See the lesson plan? Because there's part A and part B. Remember I said I was going to, yeah, because I did say that yesterday. I put both of them on there, didn't I? I just said 1 to 16? All right. We'll do a part A and part B then. All right, because we'll keep, yeah, it's on the lesson plan, 1 to 16, 19 to 30. So let's do that. So you might end up having a little bit of homework. 1 to 16, and what did I say? 19? Yep, 19 to 30. All right, and that's section 4-7, whatever page that is. 196, 198, right? So, but they're part A and part B. So this is part A, and this is part B. I'll give you 2 5s for it, okay, so that you get some extra points. That's always good. All right, that's it.